We moving on to our next talk, and we have Carola Hein from the TU Delft. Welcome, Carola. It's great to have you with us. And I'm sure, now I can also see you. Great to have you here. Carola Hein is a professor and head of the chair of history of architecture and urban planning at the TU Delft. She has published widely in the field of architectural, urban and planning history and has tied historical analysis to contemporary development. Among other major grants, she received a Guggenheim Fellowship to pursue research on the global architecture of oil. And furthermore, she received the Alexander von Humboldt Fellowship to investigate large-scale urban transformations in Hamburg. Her current research interests include the transmission of architectural and urban ideas, focusing specifically on port cities and the global architecture of oil. What has this to do with 3D printing? It sounds like a super interesting research field, and I think it's great that you are here today, because we will see in a minute that the technology is now broadening into many different fields. Because today Carola will show us on how 3D printing can provide an opportunity to reproduce missing or destroyed cultural heritage, or to express lost appearances in the cases of conflicts or environmental threats. Her research reveals challenges and possibilities of contemporary 3D printing technology in the field of cultural heritage. And she and her team are asking, can we reproduce missing elements or even reprinting historical spaces? Thank you for being with us, and I'm looking very forward to your talk. The floor is yours, and whoever has the problems with Zoom, we are now live streaming on YouTube as well.
Thank you very much for the introduction. That's always the challenge of a 50-word or 100-word CV, which may not reflect all the dimensions of what someone is doing. So maybe I should just add that coming from Hamburg, I've been involved with heritage, with the rebuilding of an old farmhouse from that time on, and also with ECOMOS and other heritage organizations. So my heart is in the fact that how can we get a better or different look at the past to better design the future. And that may also have been the start when I talked with Ulrich Knag, who's also here on the screen, and who is a partner in this project. So with that idea, we started looking at how to look at historical buildings, at heritage, and in the field of 3D printing. So in principle, you should be seeing my screen now. So yes, so then the question became, when we started looking into this, what are fields in history and heritage that can benefit from new data approaches? And I think it was that broad. And to build another bridge to my research on ports and cities, my interest is into big data and seeing how that big data can be used to create new stories on the past for the future. And in that sense, this is a facet of this larger concept. So what I would like to talk to you about now is to see how we can use these big data approaches for heritage challenges, heritage practices. And just bear with me, because it's going to be a less technical and more multidisciplinary approach. And the hardcore technical question I'm going then to play through to Ulrich Knag. So I think the project is interesting and maybe also relevant to the other ones that we've just seen, because it brings together humanities, social sciences with technology. And just as a quick reminder, whatever we choose to do in technology depends on specific paradigms, societal paradigms, as long as we decide that growth and speed are the things that we're going to, that's the technologies we're going to choose. So if we have a different idea, a different societal paradigm, then we might also be choosing different technological solutions. So in that way, I'm really pleading for the inclusion of, well, humanities and social scholars and approaches into the technological debate. So in some sense, this is what we try to achieve also with this project by bringing in larger philosophical questions of what does it mean to 3D reprint heritage? And I'll tell you a little bit more about those details. So the question that we then raised is how can we reprint uneven surfaces, curved surfaces that are covered with color or painting? Because that is something that the existing tools and the existing machines couldn't do. So there's a lot of very good scholarship on reprinting on flat surfaces, to the point that colleagues of ours in Delft reprint Rembrandts. But these machines are not able so far to work with curved surfaces at the scale of the building. So that's when we started to look for potential applications. And what you see here is the Hippolytus Church in the larger Groningen area in Middelstum, so north of Groningen, which has a very intriguing history. And so in collaboration between different disciplines, the historians went to the Heritage Agency to figure out what was the history of this particular church, what kind of archives existed, and also what kind of rebuilding practices have already occurred in the past. Because one of the questions that is then raised, well, where do you want to go back to? So as soon as you touch a historical building, you have to decide, am I going back to the moment it was built? Am I going back to some kind of restoration moment? So what am I using the 3D printing for in this context? So in the case of the Hippolytus Church, this is how the building looked around the 1970s. All the historic paintings had been covered up, and then an extensive rebuilding took place in which they, in many ways, reimagined, based on historical sources, what these paintings could have been, may have been, because you can never really go back completely to the original. So some of the discussions at the beginning of these projects were really about which period do we reconstruct. And from there on, we dove more into what does it actually mean to reconstruct it. One of the reasons for choosing this particular church was that it had already been scanned, although we quickly came to realize that the scanning that had been done from the floor of the church, some 12 meters up towards the ceiling, was not of the depth of the quality that we actually needed. And we also chose this church because it is actually under threat. The Groningen area, due to the oil, the gas exploration, so there's at least a link to the petroleum research, due to the gas exploration has been sinking, the soil is sinking, and the church has been cracking. So in this image, you see a crack running through one of these paintings. So again, due to the collaborations between historians, heritage people, technologists, we then opted to choose this specific area, this little angel here, for our pilot project. So the aspects that we choose it for were about the overall geometry. As I said, we were looking for a non-flat surface. It was about the textures of the place, the color, the glossiness. So here, this gives you an idea about the double curvature that we were actually dealing with in that space. And here is a first excerpt of the part that we were looking at. Now, the questions that this raised were multiple. First of all, when you restore a piece, And if we just imagined this church or this part of the church broke down, we wanted to reprint it. Not only is the questions, are we going back to the historic restoration with its redone design from the 1970s, but we also have to decide, do we take into account all the dirt and other stuff that has gathered on the surface over time? What do we do with cracks or irregularities? Imagine it would break down and we had to redo it. Would we pop a new piece in there that is perfectly clean and well, without any cracks, or would we try to reuse these cracks? So one of the questions is actually, can you 3D print a crack? So in this case, and we then had to go much closer to the ceiling than just the scans that had been done from the floor, we found that this crack is probably a centimeter deep, which has shifted in two directions. And we opted, and here you can see a bit more on the quality of the painting that is out here, and the multiplicity of the materials used, the surfaces used, and the question of glossiness, which is an important one for paintings like Rembrandt, which you can reprint, but the question is then how. So we had to collect these various aspects. As I said, we had to build the scaffolding to get up there, to get closer. And even though we then got to about 2 meters off the ceiling, the quality was still not perfect. And we might have wanted even better information of the scanning, but keeping also in mind that we couldn't take samples of the paint itself, which would have been necessary because even the scanning part includes different reflections, whether you're in a shadowy place, whether the sun is shining in. So even the highest resolution that we could get from a hand scanner was not always sufficient. So there's various scanning tools that we tried. All of these data sets were then translated into a virtual mesh model. And from the virtual mesh, we then went on to select this area, which included the crack for the actual reprinting. So here you can see some more information on the data. And again, here we worked with computer scientists or also in the, with colleagues in the engineering department. And from this first description, we first had a tile of the size, let's say, a little bit bigger than a passport, which included the crack, because the crack in itself also left the question, you can't print a gap into it because then your piece will fall apart. So how do you actually reproduce the gap? In the end, we opted for the solution that you see here with a very thin layer and just depth rather than the crack itself. When the people went up there, it seemed that this crack actually was several more centimeters deep, but that's not something that we could actually show. So we went through various stages of piloting from these various small scale models to bigger ones that we then used to abstract from it. We played with various types of materials, and you could see that if we used gypsum, you got a very different surface that was not detailed enough to actually show the various layers of color that we wanted and different types of acrylate and so on applications. So in the end, we said, let's go for this 80 to 100 centimeter piece, going for selecting a piece that also showed a meaningful cutout of the painting, which can go back or has been inspired by Dürer. So it's quite an important piece. But given the size of the printing machines, we had to divide it up into 4 pieces. Then that creates the question, how do you actually deal with the lines between the different pieces, so represented here as yellow and red or yellow and blue, which will always show up in the reprint itself. And how do you deal with the various holes and cracks that are not quite like the one on the surface? So one of the and another additional problem that we actually had, and this is partially due also to funding issues, was that we made it so thin, and that was also calculated by the computer scientists, that the material, when it dried, actually jumped. So what you see here is a gap between the different plates that no longer completely fit together. And we had something as wobbly as what you see here. It took a lot of physical power to bend them into a shape that allowed us to put them together. And here is the part that you may all have been waiting for, because the question was, how do we get the color on it? So for this project, after lots of discussions and back and forth, we had decided to use a foil and to put it over the 3D printed object that reproduced the various forms and elements of the board itself. Now, these kinds of foils are usually made, or the ones that we found with the help of Dick Flassbaum, was a foil that is usually used for cars, and cars tend to be very shiny. So there were several steps undertaken to get rid of the shininess. And while the shininess is important for many paintings, the kind of murals that we were looking at are made in a way that they're specifically not shiny, which again is this connection to art historians' work looking at it. So the choice for this foil also gave us the opportunity to overcome the cuttings between, more or less the cuttings between the different small plates. So you can see down here that in the background, you still get a sense that these were different plates being printed and that were then unified by the foil that was taken over it. We combined this project with a studio for architecture students who chose another section, the corner murals that you see here, to rethink what 3D printing could mean for a heritage object. So their task was to say, well, okay, if this fell down, what would we do, knowing that 3D printing for this kind of elements would want to respect the aesthetics of it, but also the particular different needs of 3D printing. So the students sought inspiration in the aesthetics, in the decoration on the walls. They translated the structural forms into different shapes. And then they came up with new potentially 3D printed and pilot 3D printed objects that could fit into the walls of the church. So they tried to really rethink the structural engineering from this 15th century church into something that would use 3D printed elements, coming up with something like this. Now, we had already undertaken our own little experiment with the color printed patterns, but we could have imagined taking this kind of a background to better 3D print our elements. Some students actually made it into clickable parts where very filigrane elements where two parts of the flower would click into each other. So our little dragon and the angel could have become clickable 3D printed parts that are put together. You see a close-up of these test prints. And all of this to say, if you get a disaster like Notre Dame burning down, we need to be prepared to have answers. One answer is always rebuilding, but at whatever scale we are working and with whatever goals, we might also want to consider 3D printing as a means to recapture these lost monuments. Or it could be a way to multiply, but again, then you come into the discussion also of philosophy and what you want with heritage. Multiply such objects, set them up in different locations, which could also become a teaching tool about heritage, and one that, well, is easier to do than just demolishing and, well, repeating this whole thing. The second project that we did, we took a different approach in terms of how we get color onto the object. So as I said, in the first case, we had found that we could reproduce the surface, even as a curved one, But then we had to solve the complexity of the color on this surface by putting the foil onto it. We did a second project with the Mauritshuis, the so-called Golden Room, to look into these two dimensions, into the horizontal and vertical dimension that you see here, to see how could we reproduce a section, again, as a pilot project of this area with color. Now, the difference here is that this object is, well, has much more continued color rather than this very difficult detailed drawing that we have for the other one. Now, in this context, and again, pleading here for multidisciplinary approaches and involving different specialists, it probably took longer to get the permission and the insurance to do the scanning into this famous museum than it took us to do the actual project of scanning and reprinting, because we had to set up the scanner to create actually the close-up of the hand scans. Now, here again, working together with art historians, they had done research, Margriet van Eijkema-Homs and Joris Dick had done research on what it was the original color of this specific room. Now, in a historic building like this, you can't just go back and say, okay, let's rip it all down and let's try how it would have looked. So one of the options would be to 3D reprint what they found would have been the original appearance of the room, which is what you see here. Now, in this area now, we choose the section that you see indicated for reprinting. And we came up with the very first pilot project here, using in the actual material coloring. Now, what ought to be gold, when you look close, actually becomes a pretty ugly yellow-green. Also, if you step 3-4 meters back, it actually looks pretty good. But it's very difficult to find the exact coloring. And you can see here that the color actually goes through the material rather than just being layered on top of it. And our experiment with foil wouldn't have been able probably to be stretched enough to cover the depth of the contours that we have here. So that in the end became the reprinted section that I showed you earlier, and remounted to show with its golden parts, the painting, the ways up to the ceiling, what this could have been. Again, for, among others, cost reasons, we had to make the material as thin as possible. And then Ulrich Knag remounted it with a structure that is actually supporting it. And I would challenge you here by saying, well, do you find an error in this reprint? Because as you see now, all of this is printed in small pieces, and it becomes really a puzzle of assembly where there is a mistake in there. So we could actually rethink this area, this structure, to how to remount it. So you can see that in here, we had again to deal with the gaps that connect different pieces. And even in the 3D printing, two pieces that are adjacent didn't quite get the same coloring. So that's an overview of the two projects we did. I hope I was able to give you an idea of the challenges and the ideas that were behind it, and potentially also about the opportunities, what it means to bring different disciplines, different approaches together and make this a much more complex project beyond the technology itself. And I would say it was also really an educational experience to be in a room and have every specialist spelling out for everybody else what they saw as the opportunities, challenges, and their own research questions. And in many ways, that's where it becomes really fascinating, when every discipline has their own research questions to deal with. Thank you very much.
Thank you very much for this fascinating talk. And thank you to connect our very nerdy technology symposium to social paradigms as well. I think that has an absolute relevance. Yeah, maybe as a first question, would you see these new technologies that, as I understand it, are not fully developed for your needs? There's still technological progress needed to make things almost photorealistic. We had a few years ago, we had Philipp Urban from the Fraunhofer IGD at the Beam Symposium, and he was talking about photorealistic 3D printing. He prints a human ear, and he prints the properties of translucency. So if light falls through the ear, it shines red. A very nerdy topic with fascinating results. However, do you see that the way we treat cultural heritage might change? Might there be a new paradigm if we have these technologies, or is it just a way of refining existing things? You ask, can we print a crack, right? So is it a different approach, or is it a refined approach?
I think it can be both, and for me, it's in particular it's a topic of discussion and a tool of teaching. So if you ask a technology, can you do that? We often get the answer, oh, in 3 years we'll have the machine that will be able to do what you want. Well, first I want to know what it means that if we want it, and what would then happen, right? And it's intriguing to challenge many of the technologies that are being developed for small objects. So anything larger than under 75 centimeters, beyond 75 centimeters, basically. Because even the Fraunhofer Institute, which you just mentioned already, they have a whole system set up to scan sculptures and things like that, at least to scan them. And then once you have the data, to reproduce them, hopefully. But even breaking up this process, what does it mean if you can generate the data, like the one we had of the church in the interior? Well, if you want to reprint it, that quality is not sufficient. So just storing, for example, scans of all the important historic buildings will not help us in 100 years to reprint them, because they will not be sufficient. On top of it, we never have the depth of the material. So you only have the surface, and if it's dirt, it's dirt. But maybe you really want to know what kind of material, what kind of construction, and other things are behind it. So I can go on and on with these kinds of challenges that we have seen by making this circle work. So for me personally, it's much more about, let's see if we connect this circle of historic research, tools to scan and to reproduce, to show, to see what kind of impact on society it has. We should be refining it, because we will always be losing objects, but we should be also thinking very carefully, how does it change and impact our way of thinking about historical objects? I mean, there's something to be said, I want to sit in candlelight in the Mauritshuis, which I will never be able to do, but maybe we can reprint it and make it possible for people. So if we can get more acceptance and more interest in heritage structures by replicating it, let's go for it, but let's not pretend that these are the original ones. So I think that's the balance we need to strike.
Yeah.
I may add on to that. Carola and me were discussing this outline, and we ended up in the Netherlands, but at that time Aleppo was under fire, so we thought maybe we do that. And then obviously the next one is, can we reprint Venice in China, just to give friends in China a simpler way to get there? And yes, it's not the original one, but it mimics the original one. And you may argue this is Disney, but you also, when you have kids, you know Disney is important. So it's an interesting field where you can easily, say, politically get lost. But what was also learned in this process is that technically, the freaks, the 3D printing freaks, as they are now in this environment, they are happy when they can do certain things. But when you ask the others, which want something being perfect, Well, there's still a lot of work to do, which is a good experience.
Gijs, do you want to add something to the discussion right now?
You're muted, Gijs. Gijs, you're muted.
We can't hear you. You have to put on your microphone.
Yeah, should be better. Yeah, no. So really interesting question to decide what to do, because yeah, as you already mentioned, all the 3D printing freaks, once they find the rabbit hole, they dive into it and they just continue until someone tells them this is not a useful technology. So it's quite interesting to see on the beginning what you would want to build as a technology, what you would need. But I had a question, was if you would get a budget and a team, what kind of technology would you try to create based on the research that you did?
I give Uli a first answer and then I try one.
It was a pain to get the digital data in a level that it could be manufactured. That was really a pain. Then the surface quality, when I'm now talking as an architect and not as a techno freak, the surface quality of the printed results, either the one with foil or the one with the polymer and pigments, it still was a bit sticky. It still wasn't the final surface. When we saw the printed art objects, Oliver, as you described it from the colleague which presented some years ago at Beam, or from the colleague in Delft who really did scans of prominent architecture, and well, I wasn't able to see the differences, even in surface quality. If you come to that level, well, then it's really nice. But then a house square meter of this printed piece of art is worth, I don't know, 50K or something. So if you unlimited the budget, then we are happy. Yeah, it's a lot of technology which needs to be investigated. And on Carola's side, it's say this obvious discussion: are we allowed to do this Disney, and how deep do we go for this Disney, and how much do we show? It's Disney.
Exactly, and I mean that's what I was going to add. If you give us this unlimited budget, I think you would make a lot of historians, heritage experts, urbanists, and so on and so forth happy by allowing them to co-shape the kind of technology that's actually going on, so that you can talk about questions of societal justice. Who gets access to it? Should it be everywhere so that every school kid can see it around the world, or should it be limited to a few places? Those kinds of questions we need to first spell out. But
That's yours.
That's exactly, but that's, you gave me the rest of the budget, right? But in order to make sure that this has a sense, because in the end, all the heritage is about having sense for all of humanity, we need to bring everybody along, and we have to facilitate conversations. And what I personally appreciate a lot is the amount of things that I've learned about technology, and even kind of forcing people to spell out for regular people what they are doing. And for me then to retranslate that and also bring the kind of approaches that I have in looking at history back to these people. And we're working to the technological people. We're working, for example, with Time Machine Europe, where those questions are at the forefront of trying to find out what big data of the past can actually mean for the future. And that includes building an identity for Europe. So I do think that with any of these technological questions, you are asking much broader questions. And in order to discuss them together, you have to have a shared knowledge base. And that's what I think this project was really great in. So if I have this unlimited budget, I would go for this multidisciplinary approach.
Thanks.
Yep, that's a nice closing word, having an unlimited budget. But I think what you achieve within a very limited budget, I think this is even more impressive, because there is no unlimited budget. So in that sense, thank you very much for this great talk.